All right, hello everyone. So today we have the following problem. Prove that x equals cosine x for at least one real number. All right, so we're going to involve functions here to start out with, and I need to, work with a function first of all. And here's what I'm going to do. I'm going to take that equation, and I'm going to subtract cosine of x from both sides. So x equals cosine x, you subtract cosine x, this is what you get. So one side is equal to 0. And what I'm going to do is this, I'm going to let f of x equal this function, x minus cosine of x. And please note that this function is continuous everywhere. And why is that? Because x is continuous and cosine of x is continuous as well. And let me just rewrite this as cosine of x. Okay, so in other words, it's like asking, instead of saying x equals cosine x, this question comes down to saying, well, where's f of x equal to 0? Okay, and we're basically now looking at a question of which we're saying maybe your function attains a particular value. So in other words, let me just write what I just said. So in other words, f of x equals 0. So we're interested in a function equaling a particular value. And this is what we're going to be using here. We're going to use something called the Intermediate Value Theorem. Okay, very famous theorem. And basically it says is this: if f of x is continuous on a closed interval AB. So sorry, when I say continuous, it's a continuous function on an interval AB. So let me include the word function here. Then f of x attains all values between f of a and f of b. All right, so what this basically is referring to is that you're given a function and it's continuous. So in layman's terms, it doesn't break up or anything between a and b. And what it says is that if you pick any value between f of a and f of b, it doesn't matter which one, anything in between, there is a value that corresponds to the function at that point. Okay. And what I like to do is, well, let's make up some numbers here. I like to make up some numbers. Let's say f of a for a moment was 7, and f of b was like 10. Then because your function is continues between a and b, there's got to be a point where your function would equal, I don't know, let's say 8. Okay. Your function equals any number between 7 and 10 here. Okay. That's what the theorem says, okay, in so many words. So basically, your function will attain any value, inclusive here, between 7 and 10, in so many words with this example. So let me go back to f of a and f of b here. So how do I apply this to this problem? Well, here's what you're going to do. As you can see here, I have a closed interval that my theorem has to work with. So we're going to work with a closed interval. And notice how I have to, the question was proving that this function was equal to 0. So I've got to show that my function basically crosses the x-axis somewhere. That's what we mean by 0. Well, what I'm going to do is as follows. I'm going to pick an interval where at one endpoint your function is positive or negative, and then vice versa on the other endpoint. So for example, if you choose 0 and pi, let's say. Okay, so inclusive of 0 and inclusive of pi. And once again, our function is continuous everywhere because it's a combination of two continuous functions. Cosine of x is continuous, x is continuous. Subtract continuous functions, it's still continuous. So my function f of x is continuous. So you get 0 minus the cosine of 0. cosine of 0 is 1, so you get 0 minus 1, which is negative 1. So we're told that if you plug 0 in, you get a negative value out of it, so it's less than 0. And if we plug pi in, you get pi minus the cosine of pi. Okay, so this is going to be pi plus negative 1, or sorry, minus negative 1, excuse me. And I guess I'm thinking ahead here. Two negatives make a positive, so pi plus 1. Okay, pi is positive and 1 is positive, so the result is positive. Okay, so we found an interval where the function value at one endpoint was negative, and the other point it's got to be positive, and your function is continuous. And let me write that down, since f of 0 is less than 0 and f of pi is greater than 0. And you could have picked any interval here, by the way, for even if the results were switched, like let's say the function at 0 was greater than 0 and the function value at pi was less than 0, the following still holds. As long as you have a function value that's in between the two endpoints, values at the endpoints, function values at the endpoints to be more specific, then the intermediate value theorem works here. So by the intermediate value theorem, there exists x in specifically 0 pi, because open, because at 0 it's less than 0 and at pi it's greater than 0, so such that f of x equals 0. Okay, so again, if your endpoints give you two y values, then your function can attain any y value in between. And in particular, when we're asking questions about finding zeros, f of x equal to 0, we're looking, the way the intermediate value theorem is applied is by picking a interval, closed interval, for which the function is negative at one endpoint, then positive at the other, or vice versa, switched around. Okay, so and then by the intermediate value theorem, f of x equals 0, which means that x minus cosine of x equals 0, which implies that x equals cosine of x for some x in 0 pi. Or if you prefer, like set notation, that's how we say it in so many words. This little thing that looks like a knee, it stands for the word in, or symbol for in, K-I-N. All right, well, hope this helps. Thank you for your time.